Hello, and welcome to our submission for the 2017 IBM Watson Analytics Global Competition. My name is Molly MacDonald, and I am presenting on behalf of my colleagues and team, Alex Cote and Robert Simmerling from Dalhousie University. The topic our presentation is focused on today revolves around whether or not greenhouse gas emissions have an effect on the climate change the Earth is experiencing. The hypothesis we have derived prior to analyzing any data is that those countries that have higher greenhouse gas emissions will experience higher temperature variances and fluctuations in precipitation. Now, the data that was used for this project was pulled from the World Bank and included data relating to temperature and precipitation levels by month for all countries and CO2 emissions per capita, as well as GDP per capita. The data that was pulled in relation to temperature and precipitation had to be done numerous times to capture all countries. This was then combined into one data file, and the mean, median, coefficient of variance, standard deviation, maximum, and minimum were derived. In addition, total was calculated for precipitation. The four datasets were merged and further refined using the IBM Watson Analytics data refinement tool. This resulted in a clean, complete dataset of 54 countries spanning the period of 1960 to 2012. The IBM Watson Analytics tool was then used to explore, predict, and understand social media comments in relation to our hypothesis. This temperature dashboard was created in regards to temperature changes by year and GDP per capita. The plot in the top visualization has darker circles clumped together around the 25 to 30 degrees Celsius range and are noted to have lower GDP per capita than those that are further along the line. These countries with higher average temperatures are experiencing higher precipitation amounts. It also shows the trend that those countries with higher GDP per capita are experiencing average precipitation and temperatures between 0 to 5 degrees Celsius. By looking at the visualization on the left, standard deviation temperatures by year are quite volatile. However, when looking at the average temperature by year, we do see an increase overall. Now, the key insight that we've derived from this dashboard is that countries with higher average precipitation and higher average temperatures, GDP is generally lower than in colder, drier countries. We also see that peak GDP generally is occurring around an average of 0 to 5 degrees Celsius. Another insight that we have is that standard deviation of temperature is rising slightly, whereas the average temperature has risen on average around 0.6 degrees Celsius from the time period that we're exploring here. Now, the next visualization that we explored related to GDP per capita by country. The darker the square, the more CO2 emissions that the country experienced. We see that Norway has the highest GDP per capita per the countries we could explore. However, it is not producing the most CO2 emissions. We see that with no shocker, of course, the United States produces the most CO2 emissions at approximately 19 tons per capita, whereas the countries with largest GDP per capita, such as Norway and Sweden, are experiencing only approximately 8 tons per capita. From this, we can conclude that there's no clear correlation between GDP per capita and CO2 emissions. However, large countries seem to emit more emissions than their smaller counterparts. There were several prediction dashboards that we visualized, the first being GDP per capita as a driver of CO2 emissions. We see that from this graph, the higher GDP per capita the country experiences, the higher CO2 emissions a country is producing. Those countries with the GDP per capita of approximately 24,000 are in the top 20% of CO2 emissions. The key takeaway from this visualization is that the two variables appear to be strongly correlated. Next, we looked at CO2 emissions as a driver for standard deviation temperature. This visualization shows that the higher CO2 emissions, the higher averages standard deviation temperature a country experiences. Now, the key insights from this, with this prediction, is that standard deviation of temperature is positively correlated with CO2 emissions. However, this is most likely due to the majority of poorer nations being situated close to the equator. Here we have a visual from the International Monetary Fund, which shows that those countries near the equator generally have a lower GDP per capita in comparison to countries such as Canada, the USA, and Australia. Those countries near the equator are generally not experiencing any major fluctuations between July and January temperatures. However, in countries such as Canada, July and January are significantly different. We then considered whether or not CO2 emissions were driving the level of precipitation for a country. First, the standard deviation of precipitation by country was looked at, where it appears that countries experiencing higher CO2 emissions have lower precipitation. This is our key insight. However, it is important to note that this is probably because these countries are experiencing less rainfall overall. Now, in order to properly make a comparison between countries, it is not appropriate to use just a standard deviation, as it is likely that countries such as Canada have much different precipitation levels between July and January in comparison to countries close to the equator who do not experience any major fluctuations. So in order to properly compare countries for this prediction, the coefficient of variance for precipitation was computed to accurately compare data between countries and create a better analysis. So there are a few outliers as noted on this visualization. However, the points on it are relatively flat, concluding that there is no real correlation between CO2 emissions and the precipitation experienced by the country. So what we're saying here is we don't necessarily think that there is a correlation between CO2 emissions and precipitation, and this does prove our hypothesis wrong, even with the climate change that the Earth has been experiencing through volatile storms in which we thought there might be a correlation. So further exploration on this topic could stem from determining how climate change is affected on a daily basis by looking at cities in particular rather than countries as a whole to know more specific precipitation levels and how the coefficient could change over a day-to-day basis rather than looking at it on an annual basis. Now, looking at the social media tool, we analyzed data from the IBM Watson Analytics platform, searching for the keywords climate change, greenhouse gas, rain, and snow. The results proved that most people were using social networks to discuss these topics in the US, where developing countries lacked a lot of data. We looked at what platform this data was collected from, noting that Twitter was the most used and Facebook pages the least. Rain and snow are commented on quite frequently through Twitter and videos, which are platforms generally used by the everyday individual. The news platform displays a large level of data, but it also seems to discuss both climate change and greenhouse gases much more than any other platforms, which was anticipated. From this analysis, we concluded that few people are discussing greenhouse gases online, that rain and snow are the most commonly used words in this topic, and that climate change is mentioned on a broad basis, which includes news, forums, and blogs, which is most likely to relate to scientific articles. Now, though our hypothesis was proven to be wrong, we developed 4 key insights and interesting discoveries to take away from this project. The first being the fact that high GDP does not mean there will be high CO2 emissions. However, there is a positive correlation between the two. Next, we noted that precipitation levels and variance has not changed with CO2 emissions. However, we've seen an average temperature to be risen from 0.6 degrees Celsius between 1960 and 2012. We'd now like to thank you for listening to our presentation today, and we hope you've learned a lot. Thanks.